Hello everyone, I'm going to talk about the answer report, which is the first report that we see on Excel after an optimal solution is found. So in this report, we're basically seeing the results of our problem. In the first table here in the objective cell, we have the unit profits or total profits, which is our objective function. And there's an original value. This is the starting value before we calculated the optimal objective function value. And the final value here gives us the optimal objective function value. This value is the largest value for maximizations and the smallest value for minimizations. In the Blue Ridge Hot Tub problem, it gives us the largest profit that we can make given the certain restrictions on our decision variables. The second table here says variable cells. This table tells us the values of the decision variables. These are the optimal solutions. So these values maximize our profit given the certain restrictions. So this is the final value, 122, and for aquaspas, and 78 is the final value for hydroluxes. So this means that in order for us to make the most profit, we should make 122 aquaspas and 78 hydroluxes, and we refer to them as our optimal solution. The last one here is the constraints table. Here we are going to be talking about the different constraints that we have. We have the pumps, labor, and tubing, as you remember. The cell value here represents the left-hand side of the constraint. If you remember, on the left-hand side of a constraint, we have a function. The value that we get here is what we get from plugging in the optimal solution into our constraint. There are different statuses of constraints, binding and not binding. Binding constraint is a constraint where the left-hand side with the optimal solution is equal to the right-hand side. So the first two constraints are binding and the last one is not binding. Slack here represents the difference between the left-hand side and the right-hand side. So if you have a binding constraint, you're going to have a slack of 0, and if you have a non-binding constraint, you're going to have some positive value here. So let's take a look at a little bit into detail. So this is the problem that we had. This is the formulation. Let's plug in the optimal solution to the constraints. For the first one, this is our constraint, and we plug in the values of 122 plus 78. That is equal to 200, which is equal to the left-hand side. So our first constraint is binding, which means it is limiting. So if you were to increase our number of pumps, so if we were to increase to 201, we could actually make more hot tubs and we could make more profit. So whenever a constraint is binding, that means that that constraint is the limiting constraint that limits our objective function from improving. The second one is 9x1 plus 6x2. We again plug in the values and we get that it's equal to 1566. This is the left-hand side value, which is equal to the right-hand side value. So that constraint is also binding. It's also limiting. How about the last constraint? If you plug in the values, we see that this value is less than or equal to the right-hand side value, and this constraint is non-binding. This means that we have some leftovers. So instead of using up all of the resources, we have some extra resources left. Slack, what is a slack? It's the difference between the right-hand side and the left-hand side with the optimal solution. For constraint 1 and 2, as we said, we're using all of the resources we have available. Slack is equal to 0. For binding constraints, this will always hold true. For constraint 3, which is a non-binding constraint, we have a slack of 168. We subtract the left-hand side value with optimal values from the right-hand side, and that gives 168. That means we have 168 feet of tubing left over.